start I said the students were getting less stupid. Yeah, don't make me regret saying that. You know after every lesson you have a homework.
Yeah. No, I'm confused with this.
Yeah, me too, I'm confused. What went wrong?
All of us are confused.
Yeah, no, I can see that.
How?
Yes, I know the second homework was RC, but the first homework was capacitors, wasn't it?
Yeah. Capacitors and capacitors now. Yeah.
You break my heart. You break my physics heart.
I'm so sorry.
That's okay. Come on. Right, well, let's have a look at the capacitors homework first. Electricity, capacitor and capacitance. Right, let's open it. And then after that, after the RC as well, number 8, very important lesson for this chapter. In fact, so important, maybe I'll just do this one, because this is really, really, really important. Really important. Capacitors. Oh yeah, I got approval for the coursework 1 for physics. I can give that to you today in ESAP. I'm also going to put it on Moodle. So you have to write an essay. Hybrid cars, yeah.
Okay,
But
how do you write that essay?
you just had an ESAP lesson on how to write the introduction. And what you're going to look at today in ESAP is the sources and what exactly you need to write about.
You made these pictures?
Yes, but they must be your pictures you made.
Where is the
Let me just check the calendar here.
It's supposed to be because we make.
Correct, the 5th, 2 weeks. Yeah.
Math course for it.
I know, your life is hard. This is the capacitor homework.
And for the
I remember showing you this as well. I'm sure it's in the video too. Yeah.
In the essay, we have to, we'll submit 3 drafts or it's just one time?
Oh no, one time deal. I can check it before you submit though if you want.
Yeah.
Yes.
So,
But that requires you to work on it in the next 2 weeks and show me what you're doing.
Yeah.
What's wrong?
I don't know how to do.
I know it's hard. It's very hard. You will get some help in ESAP. It's hard, I know, but be strong. Be strong. Be strong. You're to write about hybrid cars. You know hybrid cars? Yeah. You're going to talk about it in the ESAP later today. I'll put it on Moodle later today too. Yeah? It'll be under the section called coursework. Yeah. Okay. Look, does anybody have these done? Anybody?
I've done it, but not all of it.
You did some of these? Alright. How many?
Okay, let's solve it now. 3.
Okay. So, wait, listen. We'll take turns. I'll give you exactly 1 minute per question because they're short. So 1 minute starts now. Question 1. Go. 10 seconds. time's up. Let's have a look. 100 and 150 are connected in series. So it's like this. Come on. 100 and 150. Yep. So the rule is 1 over C equals 1 over 100 plus 1 over 150, correct?
Yeah.
Yeah. So what's that? Something over 300, 5 over 300, 1 over 60?
1 over 60, yeah.
Yep. So then C,
60.
60 microfarads.
This is for series or? for-
Yes, this is for series. Yes. Okay. Number,
What is what's
that's a 5. Thanks. Right. Next. 1 minute. Go. Ding. Time up.
Yeah, and do question 3.
Oh, good for you. Right, 50 and 200 in parallel with a 6 volt. 50 and 200 in parallel. Is it 50 micro?
Yeah.
50 micro, and what did I say the other one was? 200. And a battery?
6 volts.
6 volts. And I want the charge on each. So how do the charges combine here? They add, don't they?
Yeah.
Q1 and Q2. So the total charge is Q1 plus Q2. Yeah. So you can get the charge on each if you want and just add them together. That's one way to do it. Or the other way to do it is to add the capacitance and get the charge that way. What did you do, Fwang? Did you get here and add the Q's, or did you first add the C's?
C.
You add the C's first?
Yeah.
Yeah, that's fine. That will work also. So I'm going to do it this way and see if we get the same answer. So what's the formula for Q?
C1B.
Yes, C1V and C2V. But the V is the same, it's 6. And C1 plus C2, 250 micro. What's that? 1,500 micro unit coulombs. Yeah, which I believe if I divide this by 1,000 is 1.5 millicoulombs, isn't it? My goodness, I think so. Let me double check. It is indeed. 1.5 millicoulombs?
Yeah.
Great. Number 3. 1 minute. Off you go.
It's long, so it's 2 minutes.
Okay, 2 minutes, fine. You got number 3 already?
So,
Yeah. So far your answers are right?
Yeah.
Good. Well, why don't you try number 4 then?
What is number
Oh, good.
4 talking about?
Yeah, good question. What is number 4 talking about? You did number 4? And you got it?
I think.
Okay. Right, let's have a look at number 3 now. So, in number 3, we have a 100 micro, a 200 micro, and then a 300 micro. Yes? What did I want? I want to charge on each of these, didn't I?
yeah.
So, here this is Q1 and this is Q2.
Yeah.
So let's get
So the
Q1, oh yeah, and also the voltage,
12.
12 volts.
But the 300 was added later.
Oh, the 300 is not at the beginning?
No.
No, I think so, yeah.
And then connected.
Yeah, the 300 is in series.
Yeah, that's what I meant, yeah.
Comparison,
Yeah. Right, actually you're right for one, this is more than 1 minute. Yeah. What's the problem here with this one?
Series and parallel.
Series and parallel. So I think I'm going to add all the capacitance together to make just one, make my life easier. So these two come together to make 300, these two.
1 over 300.
And then this one with this one, that's 1 over 300 plus 1 over 300 is 2 over 300, which is 1 over 150. So in total, how much have I got? 150.
150 or 1 over?
No, this is 1 over C, remember?
Yeah.
And the voltage?
So,
So what's the charge?
Well,
CV. So it's 12 times 150 micro. Huh? 1.8 millicoulombs.
okay, so we can't use like 1800 microcoulombs.
Yes, you can. Yes. Now, I also wanted to charge on each capacitor. Yeah, so if we go backwards, the first two made 150, and the second two made 150, micro and,
what's the
what I'm doing, microfarads. Now what I'm doing, Adnan, is, now remember I add these two together to make 150, oh sorry, this one is
300?
these two added together to make 300, and this one was 300, sorry. So these ones are both 300. Now, what do we know about their charge?
Guarantee is
The charge is the same,
yeah.
and also it should equal to the total,
Yeah.
1.8 millicoulombs. So now what you have is this one here, you know this one here is 1.8 millicoulombs, and these two together make 1.8 millicoulombs. And how do the charges combine here? If this is a Q1 and this is a Q2, how do they combine? They add, don't they? So this one plus this one must make 1.8, and this one here is also 1.8. Yeah. Right, so the last part now is quite tricky. How do we get the charge on each of these? So, what's the formula for the charge on the first one? Q1 equals C1 V1, and then on the second one, Q2 equals C2 V2. But what can we say about the V's? The same. So V1 equals Q1 over C1, and V2 equals Q2 over C2, but the V's are the same. So Q1 over C1 equals Q2 over C2. Q1 over Q2 equals C1 over C2. What's C1 and what's C2? C1, the top, 100 and 200, wasn't it?
Yeah.
Yeah.
Same.
No, the top and the bottom, this is 1 and this was 2.
Correct.
Yeah. I know. Oh yeah, sorry. That was a different one, yeah. Where's it gone?
No, that.
100 and 200, yeah. What's wrong? 100 and 200 micros. So you can say Q1 ratio Q2 must equal 1 to 2. So you can say that this one must be double the other one. Well, I caught this one 100 and this one 200, although it doesn't matter which way around they are. You know, one of them must be twice as big as the other one. And the
We can
total...
also find, like, if you want to,
Yeah?
we can find the charge. It's the total charge. We can find the charge on Q1 and the Q2.
How?
Like it's the ratio.
No, how can we find we know the total charge is 1.8.
Yeah.
So how can we get each one individually?
We can't get.
We can. That's what I'm about to do. We can. Yeah. So we know that the charge is in the ratio of 2 to 1. So one must be twice as big as the other. And we know what the total is. What was the total here? 1.8 millicoulombs. So one of these must be 0.6 millicoulombs and the other one must be 1.2 millicoulombs. Is this one twice as big as this one?
Yeah.
Yeah. And did they add up to make 1.8?
Yeah.
They do. So it must be a 0.6 millicoulomb, a 1.2 millicoulomb, and then a 1.8 millicoulomb. Watch. When I add these together, what do I get? 1.8. And then this one plus this one, what do I get? No?
The same.
1.8.
Still same.
And what did I say the total was earlier?
1.8.
1.8.
Okay, so I have to ask something. How do we know that the charge on Q1 is 1.2 and on the Q2 is...
Mental mathematics. So you
What
have
ratio? When we
1.8, we want to split it into the ratio of 1 to 2.
Yeah.
You remember how to do this from elementary school?
Yeah.
Yes, you do. Of course you do. What do you do?
We just, if there is Q1, Q2 and there is a ratio, so it's, they both like Q1, Q2 is equal to the, like this one. So...
Oh, come on, look. 50 euros split between 1 to 2.
Yeah.
You take 50, you divide it by 3,
Yeah.
and you get whatever, 16.6. And then you multiply it by 1 to make that, and multiply it by 2 to make that one.
I'm asking that how do we know that the 0.6 is the charge on Q1?
It's a smaller one.
Which?
It doesn't matter because you can turn them around. It doesn't matter.
Because the capacitance is different for both of them.
Yeah, I know. But the voltage is the same. So the smaller capacitor will have a smaller charge, and the bigger capacitor will have the bigger charge. Yeah, now that was a hard one. Maybe. No, not too hard because I've seen this one in the exam before.
It's not hard. It's just.
Yeah.
It doesn't matter that if I write in the value is 0.6 in Q1 or Q2 is fine.
Yeah.
We just need to find the answer.
Yes. Try 4 now. 1 minute for 4. Did you get number 3?
No.
Okay. Got this? Let's have a look at it now. 150 micro holds a charge of 150 millicoulombs. What is the voltage? Or no, what is the current?
I think so, the voltage of the load and current.
Yeah. What's the Q? 150 and 150. Q is 150 micro or milli?
Micro.
Millicoulombs. And the C is 150 micro farad. No? Oh, they're... Yeah. 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 Right, and I wanted... What did I want? The voltage. So, you know Q equals CV. So V equals Q over C. So 150 milli over 150 micro.
1,000?
1,000.
No.
No.
Yeah, it's
1 multiplied 10 minus 3.
Which is 1,000.
No, minus 3.
Yeah. Oh.
Minus 3.
Minus.
Are you sure, Fawon? Check. Correct? Great. Right, last one now. Try number 5. No? Well, let's read it. A 200 microfarad is placed in parallel with a 300 micro and then charged under 5 volts, and they're fully charged up. Let's do that first. So, what have we got here? First, it's a 200, and then 300. Let's put the 200 down here, 300 here, and the voltage I said was how much?
5.
5 volts.
What does fully charge?
They just get charged up with the battery.
So it doesn't charge.
No. Right, calculate the Q on each, please. Tell me what the Q1 is and the Q2 is. Go ahead, you can do this one. Q1. I got 1.5 millicoulombs and 1 millicoulomb.
Oh,
Yeah?
I have total.
But that's fine, but I don't need the total. I wanted just each one.
Okay.
The total would be 2.5. Yes? Okay. Can I continue? Yeah, so now the next part of the story. You looking? The battery is removed and the circuit is closed. The smaller capacitor is flipped around and the opposite flow of current will cancel some of the charge. After the cancellation, what will the voltage be? Right, so watch this next part. It's a bit tricky. What happens next? You remove the battery, so it's gone. Away it goes. Now, if the current was coming in this way, this one will be positive, negative, positive, negative. Okay? Then I say, the smaller capacitor, that's this one here, is flipped around. So then this becomes a plus, and this will become a minus. So what's going to happen is, the current will move this way, and the current will move this way.
So
It'd be the opposite.
No, I mean that the both signs will be as well, like plus and minus and minus and plus.
Here and here?
Yes.
Yes. So what will happen is, you see the charge here? It will cancel some of the charge here because you moved it around backwards. Yes? So like for example, imagine I had something like this. This one was negative, this one was positive, and this one is negative and this one is positive. If I take the bottom one and turn it around, the positive and the negative, they'll cancel each other. Now what will happen is, which one will win? Which one is bigger? Which one will win? This one will win. It has more charge than this one. So in total what will happen is, this one will run down to zero. Zero charge. And what will happen to the charge here?
0.5.
0.5, yeah. 0.5. Because when this one discharges, it's going backwards, it will cancel the charge here. Look at it like this, look. It was originally going like this. Yeah. So then when you take away the battery, this is positive, this is positive.
Flip.
And it's flipped as well, but now I'm not sure if I need to flip it. Positive with negative. Actually, yeah, doesn't matter, I'm thinking about this too much. Right, so anyways, the charge cancels. I might have to double check something here, but I thought this was an exam question. Anyways, the charge cancels. So this one's 0.5 and the other one is 0. Okay. This one 0.5. This one now becomes 0. So what happens next? Will it stay like this? No. Are these in series or parallel?
Series.
They're in series. They're actually in series because it's going lined up like this. So what happens if it charges in series?
It will change the direction, like.
No, come on. What do we know about charge in series?
The same.
No, in series, it's the same. It's the same.
Yeah.
Yeah? So the charge here is going to be the same. What's actually going to happen is this guy is going to charge up this guy. He is going to give some of his extra charge to this one here. And I want to know what is the voltage. So if we have Q equals CV, we'll call this one, what one was on the top, 1 or 2? 1 on the top, okay. So we'll say Q1 equals C1 V1 and Q2 equals C2 V2. What is the capacitor on the top one? 100, wasn't it? 100 micro. And the voltage? We don't know. And then down below, Q2 equals 200 micro, and the voltage? We don't know. Which voltage am I looking for? What will be the voltage of the resulting current? Yeah, so what I'm looking for is V1 plus V2. I want to know the total voltage. Because remember, if they're in series, what happens to the voltage? They add. Yeah, so if I add these together, I'll get Q1 plus Q2 equals micro 100 V1 plus 200 V2. Do you know what? This question's getting too difficult. I am going to check something here. I'm starting to think I made this too difficult. Would you agree?
Yeah.
I thought so. Right, let me have a look here. Past papers, physics. I think it was back in 2006. It's a very old question.
Can I go to the voltage.
Yes. Oh my goodness. Alright. You know what? I'm thinking this is maybe too difficult. Let me have a look at it in the exam. Calm down. This exam, your exam will not be as difficult as this because this is an old exam. The person who wrote the exam before the new man wrote very difficult exams, so don't worry.
Who will now make the exam?
It'll be a little bit better. It'll be better than this for sure.
Who will make?
No, not me. Someone in Manchester. I won't tell you who.
Okay, so I will go for her.
Where is it gone? Must be in the next year. Sorry, I'm trying to find it. 2007.
It always comes in B.
No, A or B. I just remembered it was in one of the old exams. This is why I gave it to you. But either I made it more difficult or it is really difficult. No. Yeah. Yeah, so no, that was like the other example I did. No. Okay, maybe I dreamt the question up. I imagined it in a dream one night. Yeah. Yeah, maybe I did just dream it. If it's not in these two, I'm going to delete it.
Yay!
If it's not. No, sorry, there it is there. Yeah. Calculate the charge in A, calculate the charge in B. Yeah, and then it says oh, that's what I was missing. It says electrons flow in the direction shown in the diagram until the voltages are equal. Find this final voltage. Yeah, so what I need to make this easier is the voltages are equal. I should tell you that. Sorry, I didn't tell you that. V1 equals V2. So then this one here,
V.
it would be V. Yeah, so that would be micro 300 V. So all we need to get is Q1 plus Q2. How do the charges combine when they're in series? They should be the same, shouldn't they?
In the
Yeah.
series, yeah, in the series they should be same.
Yeah. So this 0.5, is it going to? It's going to share it between the two of these.
0.25.
Possibly. Q is. Oh, but no. Delete it. Yes. Delete the question. It's too difficult.
But it's still like that.
Yes, but only that one time, and it was a very difficult one in the exam.
So we can delete the exam.
No, Mahmoud, no. It was actually just this part of the question, which was for 3 marks, and it was quite difficult. They had to give you a little hint. The new person who writes the exams, he doesn't make them this difficult. I'll show you actually, since we have it open.
Better, it's good.
I'll show you what the new exam looks like. So for example, in the new one, do we have a circuit diagram? Yeah, like for example, capacitor 12, 6 and 3 are connected in series. Part 1, what is the total capacitance? Can you do that?
Yeah.
Yeah. Because if they're in series, what would it be? 1 over 12 plus 1 over 6 plus 1 over 3.
Yeah.
And then what they do is they put an 18, they add in an 18 that's parallel to the 6.
Yeah.
So it's 12, 6, 18, 3. And now they want the total energy, which is something we'll do later. So you can see that they're...
Okay, so it's 18 and 6 are different from the other 3. Or they are in the same...
No, it's connected with them.
No, first 12, 6 and 3 are in series.
Yeah, and then,
after
wait,
that,
listen. Then it's 12, 6, 18 and 3. Because it says all 4 capacitors.
1, 2, 3, 4, 5.
4, 5, what? 1, 2, 3,
Yeah.
4.
12 and 3
4, yeah.
in series, and
6 and 18 are in parallel.
and all of them.
And all of them together. Yeah.
I don't get it.
What do you mean you don't get it? Look, there's 12.
Yeah.
There's 6.
Yeah.
There's 3.
They are connected in series.
The 18 and 18 is connected to the 6.
So 6 and 18 are in parallel.
Yes.
Yeah.
So when in the first part, when will we find determine the combined capacitance?
Yeah.
We'll first find the one, all the 3 ones.
Yeah.
And then after in the second part we'll do it like we'll put another one.
Put another one, yeah.
Oh.
And do it again.
Oh yeah.
That's all. This is an easy one. Don't you think?
Yeah, it's the easy one, but you know the wordings are confusing.
No, it's not. It's not
like,
confusing.
It seems like that
No.
18 and 16 are then connected. After that, they are different.
I don't know about that, Mir. Right, anyways, I want to look at the next homework now, but just since I have this open, let me just see if there's another capacitor question to show you. Yeah, look here.
Are they on the movie? Yeah.
These are, yeah. A 4 micro is connected to an 8 micro. What is the combined capacitance? If they're in series, 1 over 4 plus 1 over 8.
Yeah.
And then what is the energy stored? You haven't done this formula yet. That's in a later class. The formula, you haven't done it yet. But I'll show you it if you're wondering. The energy will be a half CV squared.
It's MV squared and then CV squared.
Yeah. It's like that version of it. Anyways, we haven't done that yet. So it's a good question in the exam.
Yeah.
This one is too difficult, so let's just forget about it.
Wait,
What?
let me see.
This?
No.
This?
No.
This?
No.
This?
Yeah.
No, we deleted this.
No, I mean YMC. The unit of Q.
Why what?
The unit of the jam. YMQ.
Why is MQ? Where's MQ?
I know.
I don't know what?
What is the unit of Q?
Ah! I need the Q to get the V.
No, what is the unit of Q?
What is you need a Q?
Yeah.
You...
Unit.
Oh. Unit.
Yeah.
Unit of what?
Of Q.
Oh, you know what the unit for Q is.
It's C.
Yes.
Uh,
But what? What?
so the Q1 is C. It's C. It's not MC.
So it's millicoulomb.
Millicoulombs.
No.
What?
Why MC?
Why is it MC?
This is the sixth time about units.
Because it was 0.5 times 10 to the minus 3 coulombs. So I changed that to millicoulombs.
No.
Where? Here?
No.
What?
The Q1.
Here?
No, not this.
One.
The
What? What?
Right.
Yeah?
Write the 1 MC.
1 MC. 1 MC. I did. Where did I write that? Oh yeah, this was 1 and this was
Yeah.
1.5. And then when they combine,
No, I mean, why is 1.5 MC, but not 1.5 C?
That's what this is.
oh yeah, because when I calculated it, what's the formula? Q equals CV, and C was 150 micro.
Yeah, I train it, so we have to train it to F.
10 to the minus 6, yeah, to F, yeah. Yes.
You're doing it right.
And the V is right. Yes. The V is
Here,
right.
here. This is it here for one.
Yeah, so it will be C, not MC.
Oh, I made a mistake. Now I'm confused. Just delete the question. Delete
No,
it.
but
No,
I want
delete
to know it. I don't know much the unit.
Wait, but that was a different question, wasn't it? Yeah, that was the
Yeah.
last one. Yeah. This one here. Oh, but now it's so messy.
No, I just want to know why it's MC, not C.
Fine, I'll answer that and then we stop. Yeah?
Yeah.
Okay, why is it MC and not C? Right, so what's the formula here? We have Q equals CV, and in the question I said the C is 200.
Yeah.
So that is 200 micro. 200 micro farads. Yeah, and then what's the V? 5.
Yeah.
Oh, I made a mistake.
Yeah.
So this be 1000.
So the
Yes.
200
Yes,
multiplied.
yes. It should be
1000.
1,000 micro coulombs. No, wait, which is 1 millicoulomb. Yeah. 200 micro multiplied 5 is 200 multiplied 10 to the minus 6 multiplied 5.
Minus 6.
1,000.
Yeah.
We're good. Right. Next homework.